Hi all, welcome back to Triple E tutorial channel. Here in this video, we are going to discuss some multiple choice questions with answers related with the electrical measuring instruments. Okay, I think these questions will be very helpful for you for the preparation of junior engineer SSC like exams. Okay, so let us discuss about that. So the first question is, MC type instruments are used in option A AC, option B DC, option C AC or DC, option D none of this. Okay, we know that in the case of moving coil type instruments, deflection angle theta is directly proportional to current. And for moving iron type instruments, deflection angle theta is directly proportional to the square of the current. Okay, from these relations, we can directly see that moving coil type instruments are used for the measurement of DC, and for moving iron instruments it is used for the measurement of DC as well as AC. Okay, and dynamometer type instruments can also be used for the measurement of DC as well as AC. Okay, dynamometer type instruments can also used for the measurement of DC and AC. Okay, so the answer of this question is MC type instruments are used in DC measurement. Okay, so we can eliminate option A, C and D. Okay. Second question, MI type instruments are used in. Already we have discussed the point in the first question. MI type instruments are used in DC or AC. Okay, so the answer of this question is option C. Okay. So the third question is, in moving coil instruments, damping torque is developed by option A eddy current, option B air friction, option C gravity friction and option D fluid friction. We know in the case of moving coil type instruments, to produce the damping torque we need a strong magnetic field. Strong magnetic field. It is given by the use of a permanent magnet, so that we can say normally for moving coil instruments we are using eddy current damping methods. In addition to this, there will be air friction damping, fluid friction dampings are there, but air friction dampings, fluid friction dampings, the strength of the magnetic field is very weak, and due to the limitations of the applications of this fluid friction dampings, we are generally using eddy current damping for the moving coil instruments. Okay, so the answer is option A, eddy current damping. Fourth question, the force which produces movement of the pointer is called option A deflecting torque, option B controlling torque, option C damping force and option D distracting force. We know that for the movement of a pointer, for the case of, in the case of a measuring instruments, we need generally three torques: deflecting torque, controlling torque and the third one is damping torque. Damping torque. So let us discuss about the deflecting torque. Deflecting torque is nothing but the torque which is needed to move the pointer from the rest of its position. TD, deflecting torque is the torque which is needed to move the pointer from the rest position. So it is normally moving from the from this position to this region. So that is the deflecting force. The next is controlling force. Controlling force is the force which is needed to control the movement of the pointer. Normally, controlling torque is represented as Tc, which is always acting in the opposite direction of the deflecting torque to control the movement of the pointer from the 0th position to the required position. Okay, so Td will be always opposite, Tc is always opposing the pointer, movement of the pointer. So we can say that Td and Tc, which are always opposing each other. When Td equal to Tc, the pointer will stops. Will stops. That is the condition to stop the pointer. Deflecting torque and controlling torque will become equal. Okay. The third, to produce controlling torque, generally we are using spring control and gravity control methods. Two methods are there: spring control and gravity control. Generally, for most of the electrical measuring instruments, we are using spring control method to provide controlling torque. Okay. If we are using the gravity control method, always our measuring instrument should be in the vertical position. We need to keep the measuring instruments in the vertical position. Due to this limitation, generally we are using spring control method. That kind of instruments can be used in the horizontal position and also in the vertical position. That is the limitation of the gravity control method. Okay, the third torque that is required for the measuring instrument, that is damping force. Damping force is the force which is required to avoid the oscillations of the pointer. So if when Td equal to Tc, the pointer will get stops, but it will oscillates or it vibrates in its own steady position. So we need to stop the vibrations and to make the pointer in a specific point. For that we are using a damping force. Okay, generally a damping torque is provided by three methods: eddy current damping, fluid friction damping, and the third one is air friction damping. For generally for moving coil type instruments and dynamometer type instruments, we are using eddy current damping. Air friction dampings are normally used for the moving iron type instruments. Due to the presence of the fluids in the measuring instruments, if any leakage issues, the entire machines get damaged. Due to the leakage issues of the fluids, we are not providing fluid friction dampings, but there will be a method to provide damping force by fluid friction. Due to the limitations, we are not providing fluid friction nowadays. Normally for moving iron instruments, we are using air friction damping, and for moving coil type instruments, we are using eddy current damping. So for this question, the force which produces movement of the pointer. So the answer is option A. Deflecting torque is the torque which is needed to make a movement in the pointer. Okay. Fifth question, when using an instrument for the measurement of testing purpose, first attention should be given to the first theoretical knowledge, personal safety, surroundings and dress. It is very clear that first of all, we need to give more importance to the personal safety for every case. So option B is the correct answer. Directly we can eliminate other three options. So the sixth question is, which one of the statement is true about the internal resistance of ammeter and voltmeter? Option A, internal resistance of ammeter should be very low and the voltmeter should be very high. Option B, internal resistance of ammeter should be very high and voltmeter should be very low. The internal resistance of an ammeter and voltmeter should be very low. The internal resistance of an ammeter and voltmeter should be very high. So we need to remember that for the case of a circuit, ammeters are normally connected in series with the load or series with the supply. So the function of the ammeter is to measure the, here if it is a load, the function of the ammeter is to measure the load current or the full current which is flowing through the circuit. So the easy flow of current is possible when the resistance is very low as possible. So simply we can say that ammeters are normally connected in series with the circuit to measure the current, so that the resistance must be very low. But for the case of a voltmeter, generally voltmeters are connected across the load or across the supply terminals. If we need to measure the voltage which is or the drop across the load, then low current must flows through the voltmeter. So otherwise we can say very minimum current flows through the voltmeter. So to maintain that, the internal resistance of the voltmeter must be very high. So based on this information, directly we can say that the answer of this question is option A. The internal resistance of the ammeter should be very low and the voltmeter should be very high. So we can eliminate other three options directly. Okay. So move on to the seventh question, that is the reliability of measuring instrument means option A, the life of the instrument, the extent to which its characteristics remains linear, the degree to which repeatability continues to remain specific limit, all of this. So reliability means option C, the degree to which the repeatability to continue in a specific limit. Repeatability, continuous repeatability shows the reliability of the measuring instrument. It does not mean that the life of the instrument, extent to which the characteristics. So the degree of repeatability is the answer. Okay. Eighth question. In order to increase the range of voltmeter, option A, low resistance is connected in series, low resistance is connected in parallel, a high resistance is connected in series, a high resistance is connected in parallel. So to extend the range of voltmeter, generally we are connecting a high resistance in series with the voltmeter. This is the voltmeter. To extend the range of voltmeter, we are connecting a resistor which is series to the voltmeter. This is generally known as multiplier. Multiplier is having a high resistance. This is the case of the range extension of voltmeter. If we go to the range extension of an ammeter, here we are connecting a low resistance which is in parallel with the ammeter. So the resistance value of the shunt, here it is known as shunt. Okay, so the resistance value of the shunt resistor must be very low as compared with the meter resistance. Okay, so to extend the range of ammeter, we are connecting a low resistance in parallel with the ammeter. That low resistance is known as shunt. But for voltmeter, to extend the range of voltmeter, we are connecting a higher resistor in series with the voltmeter, that is multiplier. So to increase the range of voltmeter, we are using a higher resistance in series with the voltmeter. So option C is the answer for this question. Okay. Ninth question. If the connections of an MI instrument is interchanged, then option A, it will give a reading. Its reading will not change. It will give a deflection in an opposite direction. Option D, it will burn out. So here, if we interchange the position of moving ion. That means if we interchange the direction of current, interchanging means to change the direction of current. But for the case of moving ion instruments, we know that the deflection angle theta, which is directly proportional to the square of the current. So if the current is negative, if we take the square of the current, it will give you a positive value. So if we interchange any terminal connections of the moving ion instrument, what will be the net effect? Its reading will not change. In the case of moving ion instrument, its reading will not change. The reason is that the deflection angle is directly proportional to the square of the current. Okay. 10th question. This is the last question for this video. Okay. If two ammeters X and Y require 40 milliampere and 50 milliampere current respectively to give a full scale deflection, then okay, this question is based on the sensitivity of the measuring instrument. Okay, sensitivity of the ammeter. So the option A, X is more sensitive, Y is more sensitive, C, both are sensitive. Option D, sensitivity cannot be judged with the given information. So sensitivity means a minor change or a small change in the measured quantity must be measured. If there is a small variations or if there is a small change, in the case of one ammeter having a range 40 milliampere and the other one have 50 milliampere, so directly we can say that 40 milliampere meter will give more sensitivity, or it will be more sensitive than that of the 50 milliampere ammeter, because 50 milliampere means it will give full scale deflection whenever 50 milliampere current flows through the measuring instrument. But for the case of 40 milliampere instrument, it will give full scale deflection based on 40 milliampere current when flows through the circuit. So we can directly say that so option A is X is more sensitive, Y is more sensitive, both are sensitive. Okay. So directly we can say that X is more sensitive because of its low range. Okay. So thank you for listening. In the coming videos, we will see some other multiple choice questions and answers which will be helpful for you for the SSCG like exams. Okay, thank you.